All right, so last week when we began talking about probability, the main thing that we were doing in that, aside from the geometric probability, which was the second set of notes, the beginning stuff that we looked at was really like single events. Like if you rolled the die, what was the probability that you'll roll a 5 when you do that? Or if you maybe drew a card out of a deck, what's the probability you get a certain card? They were all single events. The only other difference that we really had was like if you're rolling 2 dice at a time, but you were looking at what happens when they roll together. But they were all, generally speaking, just these single event types of things. In today's notes, we're going to talk about 3 different things that involve multiple events occurring. The title is called Permutations and Combination, and that's going to refer to what's going to happen in examples 2 and 3. Okay, what we're going to start with right now is one of the more basic things that we can do with probability. It's actually going to be referred to as the fundamental counting principle, and you can't see that right now on the page, but it'll show up in a little bit. All right, so for example number 1, what we have is a deli that offers a lunch special if you choose one of each of the following types of sandwiches, side items, and drinks. Okay, so from their menu, for your choices of sandwiches, you have a total of 6 of them. You got ham and turkey, salami, tuna, and so on. You have a total of 6 of those. You also have four side items that you can choose from, and you have a total of 5 drinks that you can choose from there. I'm actually just going to write those numbers down just so I have them for reference a little bit later. Okay, so as an example, you could choose a tuna sandwich, potato salad, and milk. Ugh. That actually sounds kind of disgusting, but you could choose that, right? And there's this question, so you could choose that, and you can choose like totally different things that might sound more reasonable, like to me, more reasonable, a ham and turkey sandwich with some chips and, I don't know, what would I drink out of this? Maybe lemonade. I don't know where the soda is. But you have all these different possibilities of how you could choose. So we're just asking how many different ones can you choose? But then the whole question could also be turned into probability, like what's the probability that you do choose like this, this, and this? Anyhow, think of it, try and think of it, see if you can figure out what the answer is to the total number of like possible specials you can make. And try and do it this way by thinking that, all right, I got 6 sandwiches. If I start with the ham and turkey sandwich, I can choose like 4 different side items to go with that, right? And then if I start with the salami sandwich, I could choose 4 different items to go with that one. But then that also follows up with, I can choose now 5 drinks after each one of those combinations. So see if you can figure out what the total number of combinations is that we have available. All right, we're gonna check your answer here in just a second. But before we do that, this type of a problem falls under the category of what is called the fundamental counting principle. All right, now this part might seem a little bit confusing in what it says, but of course I'm going to outline what it talks about here. It says that, so this is about multiple events. So you have an event M and you're going to see an event N. Those are both capital letters here. So it says that if event M may occur M, the lowercase m ways, and event N can occur lowercase n ways. Okay, so let's pause on that. These events can be like the choices that we make. Like event M can be choosing your sandwich. And little m would then be the number 6 because you have 6 options in how that event can unfold. Event N can be choosing your side dish. And lowercase n would then be the number 4 because you have 4 side dishes there. So you have 2 events that each have a certain number of ways that they can occur. All right, so if that is all true, then event M followed by N, that means back-to-back choosing things here, is going to be M times N ways, little m times little n ways. So the number of ways that we can choose a sandwich and choose a side dish or a side item here is actually 6 times 4. And it kind of makes sense if you think of it this way, that for every sandwich you choose, you have 4 different options that follow it. So I can have a ham, and each one of these, that's 4 options. I can have salami and 4 options. I can have tuna and 4 options. So you really just have 4 times 6. You have 4 options that follow 6 like previous options there. Okay, so then what happens if you have another one? Well, this right here, product 24, is all the ways the first two can unfold. Now, if I've got 24 ways that that can unfold, and I have 5 ways my next event can unfold, you just go ahead and multiply by the 5. Okay, and this is it, really. It's kind of a neat thing here. The fundamental accounting principle says that if you have a situation like this where you're choosing from different categories and you're looking for like certain combinations of those categories, you're just going to take a product of all the different options that you have here. And let's see, fastest way to do that, I think it's 120. That's going to be 20, and then 20 times 6 is 120. Okay, probably the easiest way to do it. So you actually have 120 different ways that you can make a lunch special, which might sound a little bit crazy, but that's what it is. Or said it. All right, so I hope that the beginning part went pretty well. I hope that you looked at it and you're like, man, all I got to do here is multiply some numbers together and I get an answer. And I hope that that's the case, because the other two things that we're going to talk about are a little bit more complicated. Now, don't get me wrong, the calculations on these are not really like these impossible things that you can't do. It's just that they're going to be a little bit different, and it's also like the calculations will introduce some new things to you, and figuring out when to apply one versus the other is a little bit of a tricky thing here. All right, so what we're going to be talking about is permutations and combinations in the next two examples. This example is going to be referring to the combinations system here. All right, before we talk about like what the actual problem is and stuff, let's just take a quick look here at the formula that we got. There's a couple things in this that might look a little bit odd. One is what is going on over here. Okay, and what that's going to refer to is a combination of n choose r, and I'll explain that part in a little bit later. All right, that right there is what we call our factorial symbol. So what I'm going to do first is just give you a quick lesson on what is a factorial. Okay, so if you have n factorial. So quick example, if I had a 4 factorial, if I ever see that, what it means is that we take 4 and we multiply by all the numbers, like all the integer numbers below that one down to 1. Now, of course, multiplying by 1 doesn't do anything, but it's technically part of the definition because you could have factorial 1. Okay, so that's what 4 factorial means. If you're asked to do 3 factorial, that means 3 times 2 times 1. All right, if you're asked to do 100 factorial, I'm not going to write it. I think that'd be the first thing that you should realize is like, oh wow, that means that you got to write a whole bunch of numbers here, right? And that's kind of what it is. Dot dot dot. I'm gonna make sure I put that there for you. But it'd be 100 times 99 times 98 times 97, all the way down to 1. That is what a factorial is. Get that out of the way there. All right, so combinations. Combinations and permutations look a little bit alike, except permutations are very restrictive on the order that we have. Okay, so a combination of a selection of items in which the order does not matter. That's what a combination is. So permutations is going to be about when the order does matter, combinations when things do not. All right, what we'll have available will be n items that are there. Okay, n items are available, but what we want to do is choose r of them. We don't care what order that they get chosen in, we just need to get r of those things. So this is combinations and choose r of them. So you have a total of n, but we want r of them. The formula says that we're going to take the factorial of all the numbers available, or the amount available, okay, and then you're going to divide it by the number of items that we want to choose, that factorial multiplied by the difference of n and r factorial. It sounds crazy, but once you start putting it together, it's not too bad here. Okay, so example 2. The real important thing that you need to get out of example 2, though, is the concept that the order does not matter. That we do this, because it never actually refers really to whether or not it does or doesn't. You have to sort of figure out on your own that it doesn't, that the order is not applied here. All right, so it says, suppose that your school requires you to choose 4 books to read for summer vacation from a reading list of 12 books. That means that your n is going to be the 12. and we have to choose 4 of them, so your R value is 4. Okay, the question says how many different ways to choose the books are possible. You have to be real careful here because they don't really care about the ordering you choose it. It doesn't matter if you choose book A first and then book B second and so on. It's just how many different groupings of the books can we get out of those. Okay, so it does fit this. When we look at permutations, there's always going to be this little extra bit to the context where the order is actually a very important aspect to it. So if it's not important, just go ahead and assume that we're doing a combination like this. All right, so what we want to do is a combination. We've got 12, choose R. Oh, I don't know why I wrote that. You got 12, choose 4. Okay, so our formula, and here's the good thing, is your formula never changes on you. This is just what it is if it's a combination. All right, for the top, you're going to do 12 factorial. For the bottom, you're going to do 4 factorial multiplied by the difference of n and r factorial. So if you subtract 4 from 12, you get 8. So that's going to be 8 factorial. And then you work all that out. All right. Most calculators, at least if you have, I know for sure graphing calculators do have the factorial button on there. So you can do it that way, or if you want to, you can do the expansion to these. It turns out to not be like the worst thing in the world because a good number of the values that are in the 12 factorial are part of like the 8 factorial and the 4 factorial. Because remember, 12 is just a list of all the numbers that go down from 12 to 1. But 8 itself is all of the numbers that go from 8 down. So in a way, you can, the mental, it's not really mental math, but the arithmetic on your own is not too bad because the 12 factorial and the 8 factorial are going to cancel out everything that's 8 and down. So the top, you're only going to keep 12, 11, 10, and 9. Those are going to be the only numbers that get kept on the top because the 8 factorial is going to remove the 8 all the way down. Okay, now you still have the 4, the 3, the 2, and you don't really need to write the 1 because it doesn't do anything. So, not that this makes it like super easy as mental math to do it, but you can see how a lot of the numbers get eliminated and it's a doable thing here. In fact, even the, as I'm looking at it right now, the 4 and the 3, those two make 12. So then you can take out the 12 here. The 2 can definitely divide into the 10 and give you 5. So we're going to be looking at 11 times 5 times 9. I'm really surprised here that I can actually do all this without a calculator. I left it inside and I'm in my garage, by the way, if it makes sense. Left the calculator inside, so I'm trying to do this all without. You get 45 from that, and there's a little bit of a trick to multiplying numbers by 11. What you do is you write down the first number. So it could have as many digits as you want. You write down the first number, you then add the 2 digits together, which will give you 9, and then you write down the third one, or the second digit, which will give you your third one in the answer. And anyway, it turns out to be 495. Now what I'm going to do is pause the video. I'm going to go grab my calculator, try and remember where that button is on the calculator, then show you how it can all be done real quickly like that too. All right, so now I have my calculator. This is the 84, so I don't know what version of a calculator you might have access to, but all the calculators pretty much look like this that aren't the Inspire calculators. The factorial symbol, conveniently, is underneath the probability section. You go to the math button. Under math is where you find all the, I call it like the fun stuff. All the weird things, all the neat calculations. Anytime you're like, man, I wonder where that little like feature is, just go to the math button and it's somewhere under there. But what we do need to do is move all the way over to probability, and then you'll see it show up as number 4 there. Okay, so I can't select it yet because I haven't actually typed anything in, but we're going to go ahead and build this. So on the top, I've got 12. I got to go to math, probability 4. We're going to have 4, math, probability 4, multiplied. I don't think I have to put multiply, just type in 8 and pull up the factorial symbol. So looks a little bit funny there. It's all tiny, but press enter, and there we are, got 495. Can be worked out separately, all depending on how big the numbers are, but that's where it is in the calculator. What we're going to talk about next are permutations. Permutations are a lot like combinations, except in these the order does matter. It's very important that that as we were drawing a certain number of items from a pool of items, that they show up in a particular order. Okay, so when we did combinations and we were doing the book reading, it didn't matter what book was chosen first or what book was chosen second or third. The point was that we had 12 books and we had to choose 4 of them. Now, permutations, it doesn't matter which one happens first. Okay, so here's an example that's not the one that we're doing, but it might register with some of you. Door prizes. Say at the end of some conference or an event or a party or whatever it was, that you're going to draw names for door prizes. For that, unless everybody's going to get the exact same prize, which my experience is usually the prizes just vary, and whatever they are, they could be gift cards versus little, I don't know what else they'd be, but they could be gift cards to different places, say. So when you draw your first person, that person gets a gift card to one certain place or for a thing. The next person who gets drawn, they get one for a different one. So the order does matter in how it happens, and that's the main thing here. The calculations end up looking somewhat the same. You really just need to be able to identify what case we're looking at. Okay, so here's our formula for permutations. All right, this would be a permutation where we have n choose r, so same notation, but the p tells us that we're doing a permutation. The top is still going to be the n factorial. The bottom is still going to have the n minus r factorial. What it doesn't have is the r factorial that was in the combination. So let me show you that real quick. All right, they both have these. It's just the difference is with a combination, you're going to have that r factorial on the bottom. So fairly close to what the other one looks like here. All right, our example, an environmental club is electing a president, a vice president, and a treasurer. Okay, how many different ways could the officers be chosen from the 10 members? So here's a list of 10 people that are in the group. All right, now, not that this would be randomly selected. It's not like you're drawing names out of a hat and say, you get to be the president and you get to be the vice president, right? There's still an election that they're doing. It's not any of that. But when you look at all of this, it's not just about choosing 1, 2, 3 people out of it and saying, these are our 3 people, but it's when we choose those 3 people, one of them's the president, one of them's the vice president, one of them's the treasurer. In that grouping of people, they can take different jobs, right? So even if we choose just 3 people to be these roles, within that, I think it's 6. You have 6 different ways that they can have these different roles in here. So it's the fact that each person chosen is going to be a different role here that we have a permutation, not a combination. Once you have that figured out, the math is pretty straightforward here. We have 10 people. We're doing a permutation where we're choosing 3 people from there. You've got n factorial, which is going to be 10 factorial. The bottom is going to be the difference between these two, which would be 7, and a factorial. Now, I could go to the calculator and do all that, but if you remember what I did in example 2, and we think about this, this is just 10 counting down. This is 7 counting down. Most of the numbers are going to cancel out, and all you're going to be left with is going to be a 10 times 8 times 9. Now, I don't want to write all the numbers and show you that they're canceling out, so I want you to visualize based off of how I described the factorial before, that you can cancel out, a bunch of numbers. So if you had 4 factorial over 3 factorial, all of that would cancel down to just 4. All right, and then with that said, 72 times 10 is going to be 720. All right, but just to prove that that is right, we've got 10 factorial over 7 factorial, and we get 720. All right, so again, the beginning of the notes, just to recap of things, the beginning of the notes is the fundamental counting principle, which that's a great example for it, and I'm sure in the practice you'll see some others, you know, where you get to choose from different categories. Real simple concept where you multiply. We've got combinations. A combination is when order does not matter. And you have permutation where the order does matter.